So the point of the course is to expose you to different parts of metalworking that you're going to see again and encounter again in your life. Working with sheet stock is definitely one of those. Now this is 24 gauge cold rolled steel, but it could be a sheet of copper, it could be a sheet of aluminum, and the way we work with those is very, very similar, especially the way that we shape them. Okay? So we're going to be making a box in here that looks like this in its three-dimensional form, but is going to have tabs that run down the edges, go on the bottom. The same thing is true on the other side. So a smaller version of the same thing would be this, where we have the box, we have the tabs around the corner there, the ends get welded into those ends there. If this were copper, they'd be soldered into the ends there. We have a stainless steel hinge that we go ahead and attach the tube with using a resistance spot welder. The same box could be made through soldering. We've worked with soldering already, so I want to use some other way of attaching things with metalwork. Resistance spot welding, when I get to that, I want to show you some examples of that and where they are in the shop, because a lot of times people don't understand what the applications are for resistance spot welding. But if we look at this, the layout view, and I'll identify these as like A, B, and C as faces, so then I'll draw them on here the same way, A, B, and C. We need to cut out a piece. The overall size is going to be 9 3/4 by 8. These pieces of sheet metal that I get are 24 inches wide and 10 inches long. Now next week we're getting a new order of sheet metal, and they're going to be 8-foot long pieces, which is a little bit more manageable to move around. These 10-foot long sheets, bringing them out and cutting them to a size that's manageable is a bear. So anyways, it's 8 by 9 3/4. So I'm going to cut my 9 3/4 because I can get 3/8 out of that 24, and it's the best way to utilize this material so I'm not getting any waste in the process. So I'm going to mark on here my 9 3/4. Okay, I use the red pencil for that. After it's marked and it's visible, I'm just going to go back and look at it and see exactly where 9 3/4 hits. And then I'm going to use a table shears to cut this. So I try to limit the amount of material, limit the amount of use that we're having of machines that you may not see again. Table shears are not very common. Another way to do the same thing would be to use a pair of tin snips, and I'll talk to you about using tin snips because we are going to do that in this project yet. Okay? When I hold a larger piece of sheet metal like this, I put a pair of gloves on. Okay? When we're using the gloves in here, sanitize your hands beforehand, and when you're done, wash your hands afterwards. Okay? In the metal shop, you want to wash your hands, period. Even if we weren't involved in the middle of a pandemic here, this material comes with a thin coating of oil on it. So they spray a coating of oil on this in an effort to keep it from rusting while it's in storage where you're at. So there is a film of oil on this. So in handling it, it's going to be on your hands. So washing your hands makes sense for a lot of different reasons after working with materials and having gloves on. Okay? Move to the table shears. Mucho cuidado, no ponga las manos cerca de la cuchilla cuando está en movimiento. I don't think I have to elaborate on that. I think that's pretty self-explanatory. It said, warning, hands away from the moving blade area. So the yellow device on here is a guard to keep your hands away from the cutter. And the big blue steel piece in the back is what your blade is attached to. Okay? Your blade is not this really acute angle cutter here. It's thick stock, thick steel, half inch thick, and has just a slight bit of an angle to it. And really, the way this thing works is not by the sharpness of the blade, but by the fact that we're shearing it. So the blade is about 1.5 inches above the tabletop here, and it's about 1/8 of an inch here. So as we're cutting, the blade is bypassing here first and moving across, shearing, kind of like a pair of scissors bypass each other, from the pivot point all the way out to the ends of the scissors. Here's my mark. I want to have that mark on a side where it's very visible. So we watch when I advance this piece through. I bring that mark all the way out to where the edge of the table is, right there. Right? And on the back side, if we see a whole excess of material out the back, then we can go ahead and we can hold that when we cut. So I'm going to step down through right now. And then I have this material cut off at 9 3/4. You can see my mark right there. Okay? Piece of sheet metal that I'm not using, I'm going to set back here, and that'll be for someone else. When you use it though, do what I did. Where you saw the 24 inches, try to make best use of this material. If we cut it and we cut the 8-inch one there, then we're not going to have, we're going to have a lot more scrap than we would if we weren't thinking about it. Okay? So now, I don't even have to measure this thing. So we did 9 3/4 and it has to be by 8, right? I have a scale on here. So if I bring the back edge of this piece of sheet metal to 8 inches, I can go ahead and cut right through that. So I have my 9 3/4 by 8-inch piece. Usable pieces, large like that, we'll put in the back there. Smaller ones that are usable, we'll put in this bin here. Anything that's too small to reuse, we'll put in the galvanized bucket back there by the blast furnace. And then that gets recycled. So let's go over and lay this out.